So last Tuesday, we went on chapter 10. We learned how to use the chi-square distribution to test for independence, homogeneity, and goodness of fit. We discussed using the hypothesis testing for variance and standard deviation, as well as that was 10.3. Testing for variance. The test for variance is essentially the same as all other tests. The only complication you will have here is that there is no, your calculator cannot do it. So you will have to do it manually. You will have to learn how to use either Excel or your calculator to find the test value, to find the critical value or the p-value. In all tests, you have two essential methods, the critical value or the p-value. When you are using your calculator or Excel, p-value is best. Because it will not give you the critical value and you will need a table, or you will need to perform some operations. So I will use the next 10 minutes to quickly go over how to do the test for variance. First, how to use critical point. So you can use your calculator to find the critical point. You just go to chi-square inverse from your distribution, type the area and the degree of freedom, and it will give you the critical point. The problem I have with this is that your calculator uses the left area, Excel uses the right area, and I don't want us to get to so much confusion. But if you are someone that want to really learn it, you can go over this PowerPoint. That is, your calculator only focus on left area. Excel focuses on right area. And you know both, you can use them if you understand it. But I left it out because you already know how to test for mean and proportion. And you can use the same idea whenever you read something, how to test, because you want to determine if it is in the rejection region or not. If you can find the test value and the p-value for a right tail test is the probability that chi-square is greater than the test value. For a left tail test, probability that test value is less than. So now let's go to 10.4. Testing for two population variance. When we were doing the test for the mean, for the difference of two mean, some of you observed on your calculator that there was a pool, an option for pool. That option for pool is used when we know that the standard deviations, even though they are unknown, are the same. Sometimes we are interested in determining if standard deviations of two populations are the same or not, or if one is less than the other. So to test for the difference between standard deviation, we use the F distribution. The F distribution is like the chi-square distribution, but it has 2 degrees of freedom. degree of freedom of numerator, and degree of freedom of denominator. So when we are testing for two populations, we want to learn how to set up the test. Step one, we get two independent random samples, one from each population. You make sure that sample from population one is the sample with the higher variance. This is very important for a test in F distribution test. We want a numerator that is higher than the denominator. So the first population has a higher variance, and you observe it from the sample. Then the hypothesis is H0, sigma 1 square is equal to sigma 2 square. H1, sigma 1 square is different from sigma 2 square. Or sigma 1 square is greater than sigma 2 square. For this test of two variance, because the F distribution is non-negative, it is always a right tail test. That is, the first population is bigger than the second, not population. The variance of the first population is bigger than the variance of the second population. So even as we are doing sometimes a difference, sigma 1 is different from sigma 2, at the back of our mind, we are just reducing alpha to alpha over 2 and perform a right tail test. Suppose this is alpha, and this is chi-square alpha. Let's use that. We are already for a right tail test, you are checking if the test value is in this tail. If it gets into this tail, you reject the null hypothesis. Otherwise, you do. When you are doing now the difference, sigma 1 is different from sigma 2. Let me put this one at this level. Here, you take alpha over 2, and you are testing for this side. Knowing that the second side, which is here, we don't really care because it's the right hand. Essentially, what we are saying is that if you are asked to test the difference between two variants, double the p-value that you get before you compare it to alpha. Or divide alpha by 2 to compare it to the p-value you have. But generally, I give you a right tail test, sigma 1 greater than sigma 2. Avoid that confusion. But I want you to know, even though you can only perform a right tail test, you can also perform a two tail test. Two tail test is just like one tail test, it's just that this level of significance is reduced. Pardon? Oh, thank you. So, essentially, when we are testing for variance, this is what we get. Hypothesis, test value is S1 square is divided by S2 square. The degree of freedom of numerator is N1 minus 1, denominator is N2 minus 1. We use the degree of freedom to find the critical values. So to read the F distribution table, you first identify alpha to find the critical values. We say we are not using table, right? Maybe we should just persistently not use. I should just explain anyway. We use Excel. Excel can do it. So you see, if somebody presents an F distribution table to you and asks you to read, you should know how to read it. This distribution, unlike the Z distribution, is in block of alpha. It will give you, for example, here, this is for a given alpha. You will have the degree of freedom of the numerator here and the degree of freedom of the denominator here. So where at the point where numerator and denominator meet, you get the critical value. It's as simple as that. So the test for comparing two variants using a TI-83 calculator, I don't think all calculator can do it, but I believe Excel can do it. I think Excel can do it. So you will go to start, enter the values in L1 and L2, and then choose two sample F tests and complete the test. Let me look at what Excel does.
You hit the leftmost part on the Zoom meeting, you can hear us.
Here?
No, on the, go back to the names.
Here?
At the very top,
Mm-hmm.
the leftmost button.
Here?
One more.
Here. Okay, thank you. I'll click data, data analysis. This too is another issue. Data analysis. And you see here F test for sample variance. So if your calculator cannot do it, you use Excel. We are going to come back to it with an example. Yeah, I'm going to give you, I wanted to confirm we can use it on Excel for those who don't have that test on. If you don't have two sample F tests, just use Excel. Let's read the example. Can somebody help me to read? Thank you. Okay. So these are two variables. You will enter first one on L1, second one on L2. If you are using Excel, you enter first one on column A, second one on column B. Do you have data in the calculator? Then you go to start. You have data in the calculator, you go to start. If you're on Zoom, either you use Excel or you use calculator. If you have a question, don't hesitate, just speak out, I will hear you if you're on Zoom. So for calculator, enter data L1, L2, go to start test, to sample F test. For those using Excel, if you enter the data, I will come back to Excel. If you have data on Excel, you go to data analysis. By now, we should know all those data analysis, and then you will see to sample F test, to sample for variance. Then variable 1, you highlight it. Oh. Is 11, and variable 2. I like my output to be here. Yes. Sample evidence. So that's enough. Those quantities, variance. What you have on the calculator is standard deviation. Square. Okay. Any question using your calculator? So what is the test value? So in doing this, we are testing H0, sigma 1 equal to sigma 2. You can put square if you like. If you're putting square, you put square all the time. And then here, sigma 1 square is greater than sigma 2 square. Test value, F equals to S1 square over S2 square. And then what is the test value you have? Pardon? 4.5. Now what is the p-value? 0.022. Let's say alpha is 0.05. What should be our decision? Reject H0. There is enough evidence to support the claim that the variance of the first population is bigger than the one of the second population. The variance of ceramic pipe is bigger than the variance of stone pipe. Can somebody tell us why it should be like that? Why will be the diameter of ceramic pipe varies more than the diameter of stone pipe? You know what we call ceramic pipe? Made from clay. Oh, you don't know pipe? You know pipe? All people, they smoke pipe, right? You see them and they are very proud of it, smoking pipes. So there are some made ceramic, like with clay, some from stone. So what we are saying, it varies, is that you can see different form of shapes. So you can make more shapes, more type of shape with stone as you can make with clay. Do we get what we are saying here? If you have clay, you can decide to manipulate it as much as you want. So we can use, yes. Mm-hmm. Let me answer. You know why? Different from. Because it's greater than, because we want to show that ceramic pipe vary more than stone pipes. It's difficult to make stone pipes. You have to be curving the stone to make the pipe. It's easier to make clay. You know, clay is soft. You can make as many as you want. So make sure you know how to use your calculator or you know how to use Excel. Any other question? So to do a test for comparing two variants, you can use Excel or your calculator. You can also do it manually, but manually you have to compute the variance. You have to know how to find the variance. It becomes more difficult. Sometimes when I don't have time, I need to teach this one because I will give you just the variance instead of giving you data. But if you have statistics, it's more difficult to. I think your calculator has statistics and data, right? The calculator has those options. Excel only have data. So when you are entering value for data, be careful when you are given the standard deviation or the variance. Do we get what I'm saying here? Sometimes you might have to square it. Sometimes you might have to take the square root of the number that you have before you feed it into your calculator. Last section, yes. Excel. Are you using Excel or you are using calculator? Okay. So in general, when we are using the F distribution, we require, of course, the population is normally distributed. All the time we want populations that are normal. Of course, we don't want to work with populations that are not normal. Are you good? 10.5, one-way ANOVA. ANOVA is for analysis of variance. If you say you have done statistics at college level and you cannot know what ANOVA is, people will just feel like, we are not sure what you're talking about. It's not a difficult test. It's like any other one that we have done before. So why do we need an analysis of variance? We use it to test several populations. We are able to test population using the t-test, right? Mu1 equals to mu2, mu1 is greater than mu2, mu1 is less than mu2. This is two populations. But in some cases, we may want to test more than two populations. And in that case, if we are using the t-test for two populations, and we have 10 populations, we will have several tests because we will compare population 1 with population 2, population 2 with population 3, population 1 with population 3. So how many tests are we going to have? 10 combination 2. And the more tests you do, the more error you are accumulating. When you test if a student who eat in the morning perform well as students who don't eat in the morning, as well as those who don't eat as well in the afternoon, you will have more. Or for example, you want to compare the average amount of money people uh, go to the bank, those who save in the morning, go to the bank in the morning, those who go in the afternoon, those who goes in the evening, or those who do it online. It will be like 4 categories, and you want to compare if their action are the same. In that case, you might want to, if you want to compare them 2 by 2, you will do 4 combination 2 number of tests. 4 combination 2 is 4 times 3 divided by 2, that is 6. You will do 6 tests. If the level of significance for each of the tests is 0.05, that means you are going to have 0.05 times 6, which increase the level of significance to 0.3, which is very big for compared to we always using 0.0 something. So analysis of variance, we combine all those tests into one and test if the means are the same or not with a single test, which is an F-test. That is all the story you might want to see here. So let's look at this example. I want us to do it using an example. Also, you want to remember that the conditions for using the F distribution for analysis of variance is these samples all come from a normal population with the same variance. That is, the populations have the same variance. Psychologist is studying the effect of dream deprivation on a person's anxiety level during waking hours. Brain waves, heart rate, and eye movement can be used to determine if a sleeping person is about to enter into a dream period. 3 groups of subjects were randomly chosen from a large group of college students who volunteered to participate in the study. So we want to know the effect of sleep deprivation in your anxiety level. The group 1 subject had their sleep interrupted 4 times each night, but never during or immediately before a dream. This is going to classify them into level of sleep deprivation that they get. In group 2, subjects had their sleep interrupted 4 times also, but on 2 occasions they were wakened at the onset of a dream. And group 3, subjects were wakened 4 times each time at the onset of a dream. This procedure was repeated for 10 nights, and each day all subjects were given a test to determine their level of anxiety. So we have 3 groups of people that had their sleep interrupted at different levels in different ways, so as to see if that interruption is going to actually affect their level of anxiety the next day. So the level of anxiety of these individuals are collected, and we have the 3 groups here. So can you see all those numbers? We are going to need it either in the calculator or on Excel. I encourage you to use Excel because I want you to know something about Excel. We have used calculator so much, and to put it using calculator is much easier. Excel is a little bit more difficult, but it will pay for you later on when you will tell that I can use Excel. So to use Excel, you enter X1 on column 1, X2 on column 2, and X3 on column 3. If you were to use your calculator, it would be L1, L2, L3. And then everything will go the way we were doing before. But before we get to that, I will be explaining what will be going on. Yes. Just X1. This one is working manually. So I don't have it separate. So ignore the square. L A X1, B X2, C X3. So skip x1 squared. You have data on your calculator or Excel? My temptation is just show you how to do it, but you have to know what you are doing. So we call this analysis of variance because it is working things out as if it is about variance. If the means are the same, then there are two methods of assessing the variance, which is going to lead to the same answer. So we are going to have what we call sum of the mean square between and sum of the mean square within. So what we are saying is we have three samples. What is the sample size for sample one? Sample one. Sample size. Sample two. Sample three. So we have three different samples, right? Even the size are different. So we are going to do as if we put them all together. And when we put them together, we will call it the grand sample. Three samples put together give us the grand sample, for which we will have the grand total, and for which we will have the sum of the square total, for which we will find the total mean of those big samples, and we will want to find the total variance, that is each value minus the grand sample mean. So remember that we say S squared was equal to sum of x minus x bar squared divided by n minus 1. And sigma squared equal to sum of the x minus, we use mu here, square divided. This n minus 1 is the degree of freedom. So we want to recall also that the sum of x minus x bar squared was equal to sum of the x squared minus sum of the x squared. So we are going to use those. So when we say sum of the x total, it means we add every number, sample 1 plus sample 2 plus sample 3, all the total, and then we do the sample square. So hypothesis for analysis of variance. The null hypothesis is that these samples come from population with the same mean. Actually, it just means the same average for all. They come from the same population. Mu1 equals to mu2 equals to mu k. K is the number of group. H1, be careful here with H1. When I do multiple choice, I will say H1, mu1 is different from mu2, different from mu3, different from mu4, and so on, which is not the right thing to say. Either you all have the same amount of money in your pocket now. If it is wrong, what that means is that at least two of you don't have the same. Are we getting me? If I say you are all of the same age, my statement will be false when two of you can prove that you are not of the same age. I don't need to say that A does not have the same age as B, B does not have the same age, and that that doesn't even make sense to say mu1 is different from mu2, different from mu3. It doesn't really make sense. And you say 2 is different from 3, different from 4, different from 5. It might be true if it is like that, but I can still say different from 2 here. If I say 2 is different from 3, 3 is different from 4, 4 is different from 2. Is this statement right? You see here, it means 2 is different from 2. So we don't write several inequalities to replace the equalities that is on H0. Do we get what I'm saying here? We only say at least 2 of the means are not the same. So it fails because at least 2 of the means are not the same. So the sum of the square is that top difference. Sum of the square of the deviation. The sum of the square is that one. So we have 2 ways of expressing the sum of the square. So now, the sum of the square between is the difference between the sample mean for each group and the sample mean for all of them put together. So you want to see how each sample mean depart from the ground sample mean. That is our deviation that we will square and multiply by the sample size. Taking that sum, give us what we are going to call the sum of the square when we compare each sample to the ground sample. So we are going to have an expression, SSI, to means the sum of the square of sample I, sum of the square of sample 1, sum of the square of sample 2, sum of the square of sample 3. So the sum of the square within each sample is the sum of the square for each of the sample put together. So then we are going to take the mean of the sum of the square between, that is dividing it by what we are going to call the degree of freedom of the numerator, and the sum of the square within, mean sum of the square within. That is what we are using for ANOVA. So ANOVA is going to try to check if these samples were coming from the same population, then the mean sum of the square between and the mean sum of the square within are going to be the same. Essentially, we are saying that if they were sampled from the same population, the way by which we get the sum of the square will not be different. And we express that difference by saying that the ratio is 1. If you say that A equals to B, that means A divided by B equals to 1. That is actually what we were doing with the F distribution for the sample. When we say sigma 1 compared to sigma 2, we just divide sigma 1 square by sigma 2 square. If it is greater than 1, then. So the F distribution starts with 1. So the mean sum of the square between will be sum of the square between divided by k minus 1. And the mean sum of the square within will be sum of the square within divided by n minus k. Actually, sum of the square total is so the within is taking each sample and its sum of the square. So the test value now is sum of mean square between divided by mean square within. Remember, there is between and within. Between is bigger than within. So if when the population comes from the same variance, the ratio should be approximately 1. Between is bigger than, naturally between is bigger than within. Remember, as I said, make S1 bigger than S2. So we are going to do mean of the square between divided by mean of the square within. Somebody's getting tired? Yes or no? Okay. So we are not going to do all of this. I want us to go and use the ANOVA. Having these results here, go to wherever you want to, whether Excel or calculator. I am advising Excel. We have our data on Excel. Enter your data in column A, B, and C because there are 3. If there were 4, we go to D and so on. Then we go to data analysis and we choose ANOVA single factor. ANOVA single factor, and we click OK. Are you here with me? I'm going to highlight, look at what I will do. I don't know why it's not. Highlight all these 3. Just make sure that you have a square that contains all the numbers. Do you see what I've done? I put a square on the numbers. So it starts from A1 to C7. It doesn't matter with the spaces that are there. That's the advantage of the calculator. You don't do all that highlight. That is the little difficult part of Excel. To remember that you have to highlight all. Then I come here, output range, and I click here. And I will take this. Because I have things here, that's I want to cover this one. It might not work, but you should do your own. You might have nothing there. So I enter my values because it was squeezed and I didn't know there were stuff there. So I'm going to click OK. It's going to complain about that, and we have this. So now we want to read what we have on Excel. So if I ask you, what is the sum of the square between? Can you tell what is the sum of the square between? $70.4, right? Sum of the square within groups. What is the sum of the square within? Sum of the square within? Is that what you have? Okay. What is the sum of the square within? This is within. What is the sum of the square within? 63.96. What is the degree of freedom of numerator? Degree of freedom of numerator is number of category minus 1. How many category do we have here? 3. So it's 3 minus 1. Okay. So the means of the sum of the square between is 70 divided by 2, which you can read from Excel. Everything is there on Excel. So, but sometimes I ask you these questions to make sure you know what you are talking about. Now, the mean sum of the degree of freedom, what is the degree of freedom of the numerator? Numerator, between or numerator. You look at the one that is bigger, that's numerator. What is the degree of freedom of the numerator? What I mean bigger is the square, sum of the square, the bigger sum of the square. What is the degree of freedom of the numerator? 2. Degree of freedom of the denominator is total minus number of category. So what is the test value? F. 8.2. And the p-value, 0.0039. Is it significant? Do you know what it means actually to be significant so far, based on what we have been doing? When somebody just asks you, is it significant? It means, is it getting to the critical region, or is it less than alpha? So we significant for real, except some cases like independence and homogeneity, goodness of fit, which the null hypothesis is generally the claim. Most of the time, the claim is what is not none, what is new. So for that reason, when somebody just say, how significant is your test, is asking how small is the p-value. And the p-value is very small when it's less than 0.05 or 0.01, depending on alpha. So if we take alpha to be 0.05 or 0.01, will this be significant? What we mean by significant is less than alpha. If alpha is 0.01, is this p-value less than 0.01? 0.01? It is less than, right? When it is less than, what it means is that you reject the null hypothesis. Meaning that, no, those samples are not the same. Or it is not the same thing. So there's a lot of things that people claim is the same. Like learning face-to-face, learning at home, learning by correspondence, by the head, learning online. You want to compare it, they are the same. Somebody might just say, no, that's all what it is. Is when they pay people at the end of the month, or when they pay them twice a month, or when they pay them weekly, is it the same? There are a lot of things we want to know if they are the same. When they are not the same, we may now want to know where is the trouble. It might not be the same, all might be the same except 2. And it will prove that they are not the same. So this is how you do ANOVA. The questions I may be asking you is, sometimes I ask you what is the sum of the square between, what is the sum of the square within, which you can see by reading Excel or your calculator. You can play around with your calculator as well, yes. Yes, I will ask you to, well, you will read it from here, from Excel, but the degree of freedom is k minus 1 for the numerator, capital N minus k for the denominator. But if you have Excel, you have them here. How do you know which one is numerator? The bigger, kind of the bigger variance. So this one is bigger than the bottom. So what we have as this number is the division of 35 by 4. That is what is giving this F. The F is 35 divided, I'm just saying 35, but you know what it's there. That's the test value. Any other question? Let's see if there is more to say here. To work these things manually will take a long time, and so I understand when you don't even want to look at it. So make sure you know how to use your Excel or your calculator. So that is it with chapter 10. Because we have not done homework, I want to quickly go over take home problem 7 so that we'll have time to go over 8, 9, and 10 on Tuesday. Okay. I put the answer already here. I don't know if you still have your, you can also go to your Canvas and get your, what you submitted to see if you have a question. We are going through this so that as we are preparing for the final exam, the take-home problem, the take-home problems tells you the type of problem we are going to get on the exam, like we did in exam 1 and 2. As we are preparing for the final exam, you should think about, generally I give you 10 questions on the final exam. It's the same thing that you have been having, just that before you were having 5 exercises with 2 questions and sometimes 3 or 4. So now I'm going to put it separately as 10 questions, each out of 10 points, so that I can be able to take question 1 from chapter 7, question 2 from chapter 8, without having to, when I put them together, it's usually from the same chapter. So generally chapter 7, I give you like 2 questions, or three from chapter 7. I'll give you 2 from, or 3 from chapter 8, then 2 from chapter 9, and then 2 from chapter 10, something like, it's generally 1 from chapter 9, 3 from chapter 7, 3 from chapter 8, 1 from chapter 9, and 3 from chapter 10. Okay. So we know how to compute the confidence interval from the mean. When I ask you what distribution should we use, it's about determining if sigma is known. Why? Always population is normal and sigma is known. Yeah. Population is normal or sample size is large enough. Sigma is known, use the Z. Unknown, use the T distribution. And you can use calculator to find the confidence interval. In question 2, be careful about this type of question, which I like asking. The first sample is available with a size. It gives you a standard deviation that you are going to use as the sigma. And I ask you, how much more? That was used to be the little issue I had with some of your answers. For take-home problem, I don't subtract much points. But because I am already explaining to you now, if I ask this question again, I expect you to get it right or to lose more points than on take-home. You saw how it is with exam and take-home problem. So I subtract more points on exam than I do on take-home problems. So actually, if you don't realize that it is about more, that means you are giving more work to whoever is doing that research. It's not fair. So be careful when I say how much more. Question? There's no answer here? Really? Why did I do this? I'm going to put the answers. Okay, let me look for the answers. I probably choose the wrong file. Let me check this again to confirm. So sometimes some of you do that with me. I want to grade, I see no answer. This was, let me check it elsewhere. If I don't get answer here, then that's where it started. Oh, okay. So a Z distribution can be used to compute the confidence interval because there are more than 30 blue spruce trees in the sample and the population standard deviation is known. Both for T and Z, you need normal population or large enough sample size. And then the difference between T and Z is with sigma. Sigma is known, use Z. Otherwise, use T. So here, for example, we compute with E equals to 1. E is generally, when you have sample size, you can see E like within that number is E. So we find the minimum sample size to be 85, and we remember that we already have 53. So we subtract 53 from 85. Second question is essentially the same. We use the t distribution because sample population is normally distributed and sigma is unknown. So for proportion, there are two situations. Sometimes an estimate of the population proportion is given, sometimes it is not given. When it is given, you use it. If it is not given, you use half, just like a rule of thumb. And generally, when a proportion is given, you get a better result. Better results is that you require less people, less individuals for the sample. If you have a question, feel free to stop me. So here is the confidence interval for difference. Confidence interval for difference, you use the data because that's what you have here. So we find the confidence interval, and one of the numbers is negative and the other one is positive. It means you cannot say one is bigger than the other because you don't know where 0 is, where they could be equal. So you cannot conclude. You have here confidence interval for proportion. I am working the take-home problem as if you don't have a calculator, but you feel free to use your calculator and give me the answer. Please don't waste time to do all these computations I'm doing. If I don't ask you for something, don't do it. Where I see computation so far is for the minimum sample size, because calculator doesn't do it and it's not much calculation. So the difference for these two proportions is 0.01 to 0.1, which are both positive. So P1 minus P2 is positive. I am indicating how to, on exam, you can come back to look at this take-home problem if you forget, because I am giving you indication. These answers will be available on Canvas. I would fix it as soon as we finish. I choose the wrong file. So it means nobody had to really check it. So that's all. That's all for take-home problem 7. So go over take-home problem 8, 9, and 10. We will go over them. It took us less than 10 minutes to do this. But if you have questions, it might take us a little bit more, but it will be better. If you don't go over it, you will not have questions. As we say, you don't have to take your exam on Thursday. Will you get me? We are taking our exam on regular time here. If you cannot be here on the day of the final exam, make sure you are ready to take your exam on Thursday. Yes. Yes. A little different. It will be on chapter 7, 8, 9, and 10 with exercises, 10 of them. If you look at one of these exams, when I say 10, it doesn't mean it's more work. It is just that the work is not like on your exam. We will look at exam 2, for example. We were having 10 exercises before, right? Five exercises, okay. 5 exercises, 10 questions. Did you know that? More than 10 questions, actually. You see exercise 1, 1, 2, 3, 4, 5 questions. Exercise 2, 1, 2. You see that? Exercise 3, 1, 2. Exercise 4, 1, 2, 3, 4, 5. So those questions could come from anywhere. So what I'm saying is, if you look at your take-home problem now, they don't have these little questions, which for those chapters, we were learning little things that we are not putting together. So if you look at the take-home problem 7, for example, take-home problem 7, which is here. Here, the answers are there, you might not be seeing. You see, I will give you have exercise 1 here and exercise 2. Kind of, there will be more questions. I will not put it as exercises. Or do you like that I call it exercise? The problem is that when I take like this one, look at this exercise 2. Confidence interval for the mean, and this one, proportion. So I will separate it as 2 questions. I can still make exercise 1, exercise 2, 5 exercises. Exercise 1, chapter 7, exercise 2, chapter 8, exercise 3, chapter 9. But then the points are not going to be the equivalent. The exercise 9, I only have 1 question. Are you getting what I'm saying? So I only have 1 question that I will make out of 10 points. Meanwhile, in chapter 7, I might give you 3 exercises, each 10 points, and it will be 30. So I will say exercise 1, 30 points. Exercise 2, 30 points. Exercise 3, 10 points. It looks like they are not. So instead of doing, I just put question 1, question 2, question 3, question 4. But if you prefer in terms of exercises, understand that exercises are not equivalent. Do we get what I'm saying? I can understand your own observation. If you know it's the same exercise 7, all will be confidence interval. You know it's about confidence interval. All is hypothesis testing is all. If you like, I do like that. But don't complain that he gave us 5 exercises. One was just 10 points. Another one was 20. Another one was 30. Is it fine? So we understand, and you will see, I will do it that way. In that case, I will make 4 exercises. Exercise 1, 30 points. Exercise 2, 30 points. Exercise 3, 10 points. Exercise 4, 30 points. Okay? Yeah, more questions, of course. Pardon? Yeah, it's going to be. That is the advantage of coming on the day of the final. But I prepare my exam for 1 hour. If you are not going to be wasting your time doing computations, in 1 hour, you will be able to. But I don't know how you could be slow. I don't know how you do to be using computer or calculator. It down different. That's, and I put 1 hour, 15 minutes. Normally, you know, you are used to doing these exercises. You will see that calculator will take you 5 minutes to do each of these questions. And I'm not asking you to write all the literature. Even as you want to write, you can copy and paste because that's why you are doing it with your laptop. Okay? But on the final, it doesn't depend on me. That's the university rule. It's 2 hours. If you want to stay with me here 2 hours, you will stay. But hardly do students stay 2 hours. So generally after 1 hour, 20 or 30 minutes, everybody's gone. So I want you not to feel bad if you are taking it on Tuesday. I will try to come early, maybe open it 10 minutes earlier or 15 minutes earlier, but that is not the rule. Don't feel like I should add you point because it started earlier. Do we get what I'm saying here? So I'm preparing my exam for 1 hour, 15 minutes. I will come a little 10 minutes earlier. I can leave 10 minutes earlier. That will be okay. If you come earlier, as soon as you come, you will start. If you are taking it on Thursday, but on the day of the exam, it starts at the right time and ends right time. Yeah, think about any question. On Tuesday, we will have more to discuss about. Okay. We are good. Yes. You can see it from the syllabus too. Oh, next week we will take evaluation, teaching evaluation. I think you can already take it, but make sure you take it on Tuesday. Yes, everything is done. We are coming on Tuesday to go over the take-home problems. Take-home problem chapter 10 is due before class. Thank you. Take-home problem chapter 10 is due before class. I might not have said that because I was planning to do it on Thursday. So, if you are not coming for exam, you don't have to come. On Thursday, class is holding. Don't say that I cancel class. Only for those who are. No, that's the most important. That's the main cause. I would have liked the idea too, then I don't have to work. Mhm. Everything, there's no difference with what you have been doing in class for exam. Don't think anything else. Just that the configuration might be a little bit different. As I say, I usually just put 10 questions and 10 points each. But if you want, I can separate it as exercises so that you know this question is for chapter 7, this is for chapter 8, this is. But in a regular exam, you have more than 10 questions. You're welcome. Okay, we are done. Okay, guys, thank you.